Okay, so the next topic is the ever popular confidence interval. And I'm going to keep on acting as if we know sigma. As I said, we'll remove that shortly, but for the time being, just to keep the conversation straightforward without extra complexity, let's just act as if we know sigma. All right, so here is our standardized variate. So from the central limit theorem, we know that x bar, there's our variable x bar, has got mean mu and standard deviation sigma over the square root of n, standard error. Let's assume that n is large enough so that we can make this statement that our standardized variate will take on values between minus 1.96 and 1.96 95% of the time. Let's multiply, so sigma is positive, square root of n is positive, so let's multiply through by sigma over the square root of n, and then subtract x bar from both sides, and then multiply everything by minus 1, reverse the inequalities, and there you have it. Just a little bit of algebra. This statement here, these two statements are exactly the same statements. But look what we've done. From sample to sample, this is the thing that varies. Now, by doing that little bit of algebra, from sample to sample, this varies, and this remains fixed. So what have we done? We've created what is called a random interval. So we've created an interval, which is calculate x bar and subtract 1.96 sigma over the square root of n from x bar, and then add that same quantity to x bar, thus creating an interval from x bar minus to x bar plus 1.96 sigma over root n. This interval now is going to vary from sample to sample to sample to sample. Okay, is that all we can say about it? No. This interval will cover mu 95% of the time. So we've got this mu is fixed. And now we calculated this interval. Okay, this interval is going to vary from sample to sample. 95% of the time it will cover mu. 5% of the time it'll miss it, but 95% of the time it'll cover mu. That is called a confidence interval. So we're 95% sure that this interval will cover mu. Once we've done it, we don't know. Maybe it covered mu, maybe it didn't cover mu. But what we're giving you here, or what this gives us, is a recipe, or it gives us a rule that has a 95% chance of success. That is what a confidence interval is. It's a rule that has a 95% chance of success. Success being measured by, does it cover mu or not? So before we take the sample, we can make the statement that there's a 95% chance that it will do the right thing. So we've got 95% chance that it'll do the right thing. So we're 95% sure, or we're 95% confident that we will capture mu with this interval. All right? So there it is, this interval that varies from sample to sample. The interval varies because we don't know what x bar is going to be. This is fixed, that's fixed, sure. So all those things are fixed, but we don't know x bar. X bar is going to vary from sample to sample. Okay? In such a way, remember the central limit theorem tells us that how x bar is going to vary from sample to sample. So x bar is going to vary from sample to sample in such a way that this interval will have a 95% chance of covering mu. So let's think about the total cholesterol level at visit 1 from our Framingham population. Okay. If we take a sample of size 49 and assume that the standard deviation is 47.7, then what's our 95% confidence interval? It's minus 1.96 standard deviation divided by the square root of the sample size, standard error. And what we get is x bar minus 13.4, x bar plus 13.4. This interval, whatever your x bar is, when you take a sample of size 49, subtract 13.4 from your x bar, add 13.4 to your x bar, thus creating an interval, then that interval has a 95% chance of covering the true mean. In our example, we know what the true mean is. So we can check to see if indeed it worked or not, because this is, we're just doing this exercise. Okay, we're acting as if that's our population. So let's see what happens here. We actually observed a sample mean of 233.7. So our 95% confidence interval is 220.3 to 247.1. And in this case, we know it covered it. Typically, we don't know if it covered it or not. We don't know. The only thing we can say about this is before we started out, the rule was do all these things and you'll end up with an interval. That interval has a 95% chance of covering the mean. Whether it actually did or didn't in this one particular situation that you carried out, we can't say whether it actually covered the mean or not. All we can say is that you follow the rules that give us 95% chance of success. Now, here we know the answer, but all we can say is typically we follow the rules that give us a 95% chance of being correct. We're 95% confident. That's why we call it a 95% confidence interval.